Hey guys, this is the last video from Unit 1. It's going to be Lesson 7 on functions. Functions are a special type of relation. Let's take a look at what they are. So, functions, simply put, are a relation where the domain does not repeat. Does not repeat. So x does not repeat. And that's really all there is to it. Let's see if we can dive in and look at some examples of some functions and some not functions and see if we can understand what is going on there. All right? So, let's write a relation. This is going to be example 1. All right? Let's write a mapped relation. Mapped representation of a relation. Okay, so for the domain part, we're going to have -2, 0, 3, 4. And then for the range part, we're going to have -3, 6, 9. Okay. And then it's going to be mapped this way. The -2 is going to be mapped onto the -3. The 0 is going to be mapped onto the 6. The 3 is going to be mapped onto the 6. I got a little bit crazy. Hopefully that makes sense. And then the 4 is going to be mapped onto the 9. Right? So, the question is, and this is the question that we're going to ask on these kind of problems, is this a function? Yes or no? So this one right here is a function. Okay. Now, we have this 0 pointing to a 6, and we have the 3 pointing to the 6. So they're pointing to the same number. So, but for each member of the domain, they're only pointing to one member of the range. So let's do a counter example. So this is going to be example number 2. List the domain over here as 5, 6, 7. And we're going to list the range over here as, let's say, 2, 5, 9. Now, we're going to map it this way. We're going to map the 5 onto the 2, and we're going to map the 5 onto the 5 as well. And then we're going to map the 6 onto the 5, and the 7 onto the 9. Now, this one, I've already basically said, is a no. This is not a function. And the reason it's a no is because of this part right here. This is the important bit. Because that 5, that member of the domain, has 2 possible outcomes, that makes this not a function. Let's look at another type of example and see if we can continue to understand what's going on. So this is going to be example number 3. All right. So let's do a set of ordered pairs. And let's do the ordered pairs 2, 1. And and 3, -2, and 3, 1, and 2, -2. Okay. So is this a, gosh, sorry, y'all, having some coughs all of a sudden. Is this a function or not? See or no? It is not a function. Not or no, right? Why is it not a function? So take a look at it. Give yourself a second to see if you have already spotted it, right? Make sure you're playing along, because if your brain is engaged, your learning is much more engaged, right? So the reason this is not a function is because this 3 right here and that 3 right there. So those 2 3s in the X spot repeating is the problem. It is not, I repeat, not because of these 2 -2s that repeat. That's okay. The Y can repeat all it wants to. The X can't, though. Okay? Does that make sense? So that's whether something is or is not a function. What about for pictures? I should have brought this in already, but I'm going to bring it in right now. That guy in. That looks fine. Let's give it a different color. How about, where's the Doomaflotchy? There it is. That looks fine. And then let's kill that off and make something right with. What about for pictures? What about for graphs is our next question, right? So, is this a function? Yes or no? This one is a yes. That's a function. So what about this one? Is this a function? This is also a yes. Okay. What about, I'll explain in a second. So hold on to your hats. What about, I'm getting a little crowded here. What about this one? This one is a no. That one is not, in fact, a function. So how do we test these? So let me bring these other 2 back up here. So the red one, why is it a function? And why is the yellow one a function but not the blue one? So again, it's the same idea. X can't repeat. So the test we use for, excuse me, the test we use for graphs is we use what's called the vertical line test. Okay. So the way the vertical line test works is we take and we move our ruler across it. And if at any point a vertical line is touching our graph more than once, that makes it not a function. All right, so let me put those other ones back up. Now, if I draw vertical lines on these ones, so if I draw a line vertical here, it's only touching this yellow one once. It's only touching it once. And anywhere, and we can keep on doing this over and over again, it's only touching it once. So then if we look at the red one, this one, it's only touching once. It's only touching once. It's only touching once. And as we move our ruler or our pencil across that graph on these ones that are functions, it's only ever touching the graph once. And so those ones are functions. But if it's touching it more than once, what did I do? Oh, no, I did it right. But I don't need this. There we go. If it does touch it more than once, then that is not a function at that point. So now we're not quite done. I know it feels like we're done, but there's a little kind of sub lesson inside of this lesson, and this is typical. Sometimes different books and different people will split this up into 2 lessons, and sometimes, what am I doing? Oh, I accidentally clicked something. Sometimes we'll split it, keep it in 1 lesson. We're going to put this into this same lesson. So a sub heading in this lesson is what's called function notation. Function notation, right? So the basics, absolute basics of function notation is that, if we have a graph, we have y and we have x. Now, for function notation, we have a new way to write y, and that's like this. This, I'll write down how to say this in a minute and what this means and all those things, equals y. Now, how do we say this? What is this? This is not. It's first thing that's really important to understand is that, oh, I must have hit caps lock. Give me my brush back. Give me my eraser. Whoa, something went crazy. There we go. There we go. There we go. This does not equal, this is very important, this does not equal f times x, okay? What this does mean is this is f, we say this f of x. And to expand on this is how we say it usually when we're talking, where we're speaking out loud and all these things. The more full way to say what this is f is a function of x. Okay, so what this really is telling us is this notation is telling us that x is the independent variable. You're like, but earlier in another lesson, you told me that x is the independent variable. Well, it is, but x is not always x. Sometimes it's t or p or jellyfish. Well, probably not jellyfish, but you never know. So whatever variable in here is the independent variable when we're writing a function and we're doing all these things. And we're gonna learn how to a way to use this for substitution in a minute. So it tells us that's the independent variable, and it tells us that all of this together is the dependent variable, or you could call it the name of the function itself. Okay, so that's what this is telling us. Now, how do we use that? Okay, how do we use it? So we're gonna learn how to do a thing with an example, because I think in this case, it's gonna be the easiest way. I don't remember what example number we're on, so I'm just gonna put example. You can look at your notes. I've got so many layers going on in this particular lesson that I don't even know which one to click. So I'm not gonna waste any of our time figuring that out. You figure out what example number this is and put it in your notes. Sounds great. So the example is for f of x equals negative 4x plus 7. Find each value. excuse me. Find each value. So part A of this question, we want to find f of 2. Okay, so this is actually really easy. All we're going to do is, to start this, is we're going to rewrite our equation, our expression, with a parentheses everywhere where the x is, where the independent variable is. So -4, open parentheses, close parentheses, plus 7. Then we're going to take and we're going to substitute this in for x. And then we're going to simplify it. -4 times 2 is -8. Bring down the plus 7. -8 plus 7 is -1. Which means that f of 2 equals -1. Easy peasy, lemon squeezy. No big deal at all. No big deal at all. Let's do uno más in, well, yeah, no, let's go ahead and do part B, and then we'll do one more example. Yeah, I want to include that example in this video. It's not too long anyway. So we're going to find f of -3 plus 1. Ooh, okay. So this is a little bit trickier, right? So we're going to do this, and then we're going to do that. Now, the way we're going to write this is, oops, that went a little crazy, didn't it? Okay. The way we're going to do this is we're going to, first of all, put our expression with -3 in for x. So the same idea as over here. Use a different color this time. Keep it all separate. So -4 times -3 plus 7. Then we're going to add 1. Easy peasy. -4 times -3 is positive 12. Bring down plus 7 and plus 1. 12 plus 7 is 19. Plus 1 is 20. That's no big deal either. It's almost like math makes sense. OMG. Let's see. Yeah, let's do one more example. And then we're going to be done with this lesson and this unit. Hold on to your butts. I don't know. What's his face from Jurassic Park? If h of t, see what I'm talking about? It's not always x, right? Equals -16 t squared plus 68 t plus 2. Find, for part A, we're going to find h of 4. So same plan, right? We're going to rewrite it, but with parentheses where the variable lives. Plus 68 times parentheses plus 2. Then we're going to take and we're going to put a 4 in there. Okay, no big deal. No big deal at all. So then we're going to walk through this and simplify this on out. So, excuse me. Negative 16 times 4 squared, so 16 times 16, or negative 16 times 16, is negative 256. And then 68 times 4 is 272, so plus 272. Bring down our plus 2. There we go. So then negative 256 plus 272 plus 2 equals 18. So h of 4 equals 18. One last bit for part B, because this one's going to be a little bit more differenter. It's going to look scarier, but it's not going to be scarier. So what we're going to do is we're going to find 2 times h of g. Whoa. What? So we're going to treat this one kind of like that plus 1 up above previously. My goodness, excuse me. So we're going to put the 2 times, and now we're going to rewrite it with a parentheses everywhere the variable is. So negative 16 times squared plus 68 times plus 2. I'm going to close that up. Then we're going to take and we're going to substitute a g in for the variable. That's not too tricky. We do need to simplify this, clean it up a little bit. So in here, we can just drop the parentheses. It's no big deal, right? G squared is g squared, and g is g, right? No big deal. So equals 2 times negative 16 g squared. Now it's important. A place that I can see making a mistake here would be accidentally squaring this 16 or the negative 16, but it's only what's inside that's squared. So only that g is squared, not the 16. So that is one place I could see making a mistake on this particular problem. So don't make that mistake. It's 2. Now, what are we going to do with this 2 on the outside? Well, we've seen that before a few lessons back. We're going to distribute it. We got to distribute it times all 3 things. So 2 times negative 16g squared is negative 32g squared. And then 2 times 68g is 136g. So plus 136g. And then 2 times 2, you've been knowing that for a long time, is just plus 4, right? So 2 times h of g equals negative 32g squared plus 136g plus 4. And that's it. Thanks for watching, guys. If you are one of my students, you can do your homework and probably study for the test and all of those things. And if you are not one of my students, thanks for joining us. You can find more information about what we do at emberlearningslabs.com. Make sure you hit that subscribe button and like and ring the bell and all those things. We've got all of our Algebra 1 course lectures for free here on YouTube. Thanks for watching, guys. Have a great day.